right, so I'm going to finish up my ACT geometry packet. So we already did this packet. We just got to do these back two problems. And hopefully you guys have already taken your second practice ACT test. I'm not counting it like a real test, like you have to get a certain amount right. You just have to do it, okay? So I want you to try it. But hopefully you've already done that. If you haven't, stop, take that test, get it done, okay? But right here we've got 1, 2, 3, 4, 5, 6 geometry problems. They are more difficult, especially because Utah has less geometry than the rest of the nation because we have that secondary math 1, secondary math 2 stuff. It's called integrated math, which means that what we do is we give you a little bit of algebra, a little bit of geometry, a little bit of algebra 2 in every grade, right? In all three of those, first, second, and third. And so you don't get the emphasis of geometry like the rest of the world that does algebra, geometry, algebra 2, whatever, where they have a whole year emphasized. So this is a struggle. So what I would say is give yourself 6 minutes solid. Maybe more if you need to, but I want you to try these problems again. Do it if you know how. Put a star and come back to it if you know how it's taking you more than a minute, and then circle if you need to skip it. Oh no, whatever. Okay, here we go. I'm gonna dive in here. So it says 2 angles are supplementary. Well, Miss Cooper drew that terrible drawing of her after supper, which means that I know it's 180, right? So I'm gonna draw something like this for my own mind. And it says it has a ratio of 1 to 4. Okay, so this is 1 x's, and this is 4 x's. What's the size of the smaller angle? So here's where students get kind of troubled, is they want to like combine these somehow, like make it like 1 and 3 or something. No, it's 1x and 4x, which makes a total. So this 4x and 1x has to equal up to 180, which means it's 5x equals 180. So then I would divide by 5 to solve for x, and it's 36. Okay. Looking at number 2, it says A, B, C, D are parallel and E is the transversal. So I hope you saw those are corresponding. Remember how we talked about never eat sour watermelon or soggy waffles or whatever you say, right? But here's the thing. It says if this is 132, what's this guy? Well, they're both obtuse. So I hope you said 132. All right. Now we're getting a little tough, more difficult. Problems here. It says A and B are parallel. These lines, we should have maybe written it a little bit better. A and B are parallel. The triangle at the bottom of the figure is isosceles. That is huge information. Oh, I wish I could use my colors. Isosceles means that this side is equal to this side and that this whole thing is a triangle. That's what they're kind of getting at. So that's important. And it says, what is y? Thank you for all that information. It just looks like there's not enough, right? So how do we get to what we need? Okay, well, we've got to figure out that because this is isosceles, that these two angles must be equal. All right, so this right here, so I can't compare these two because they're on different transversals. We can see these are parallel, but can you see that this one's acute and this is obtuse? So they are equal, but these are linear or supplementary. So the best way I can describe it is for me to find this angle, I would have to do 180 minus that 4x. And then it's going to be equal to this 2x plus 30 because, again, these are alternate exterior angles and these are supplementary angles. So that's the relationship, but they're equal right here. This one's equal to this one. So I've got to get my x's together. That's top priority. Then I would solve for x by subtracting 30 and dividing by 6, and so x is 25. Well, all that did was tell me what x was. So right here, if 4 times 25, that means that's 100. That means this is 80, and this is 80. Let's just see. 2 times 4 is 2 times 25 is 50. 50 plus 30 is 80. Yep, there we go. But the problem is still asking, what's y? So you've got to know that the whole triangle, a triangle adds up to 180. So if I subtract this first 80 down to 100, if I subtract the other 80, I'm down to 20. All right, moving on to number 4. If the measure of APC is, as means equals, 81 degrees larger than, so I'm going to add 81 to something, larger than the measure of angle DPB. So I'm going to make that X. And it says, and the measure of CPD and DPB are equal. Strange. Okay, but again, we see that it says that this is a line, or it creates a supplementary, which means 180. So I've got 1, 2, 3 X's, and 81 adds up to 180. Solve by subtracting 81 and dividing by 3. Okay, so this is 33, this is 33, and this is 33 plus 81, whatever that is, 114. But the question is, what is CPB? CPB is this whole guy. So it doesn't want 33, which is a distractor. It wants 33 and 33, which is 66. Oh, gosh. Gotta watch the question. Okay, another toughie. So it says AB and CD are parallel. So this is parallel to this. And we can see, even visually, these are not parallel. Okay, but it says, what is A plus B? Well, right away we know B is 20 because of vertical angles. So we've got A plus B, that's the question, and we know B is 20. So we know A is going to be the booger, right? That's really, that's where we are. So looking at this transversal is how I'm going to have to find A. And so if this is 40, I know this is 40, and this is 40, and this is 40. Yeah? And then, maybe I use a pencil. I need to find this angle though, which is going to be equal to here. And because that's supplementary, I do 180 minus 40 is 140. So this is 140, this is 140 because of corresponding. And so we've got 140. And 140 plus 20 is 160. Okay, last one on this side. It says we have a rectangle ABCD. So I'm going to draw, I'm just going to use this guy to help me. So A, B, C, D. It says both diagonals are drawn and intersect at point E. So diagonal means across from corner to corner. And it says it intersects at point E. Okay. And then it says, let the measure of AEB, AEB, X. All right. BEC, BEC is Y. CED is Z. Find the measure of this guy. So they're saying, what's this in terms of X, Y, and Z? Well, thanks. So, I don't really love this question, but it's okay. So I'm trying to figure out what this guy is. So ideally, we could have said it's 180 minus X, right? Or we could have said it's, but it's not 180 minus all those. That would be 360, so it's not that guy. It's not 180 minus Y. It's not 360 minus X and then adding. If it would have said minus and minus, it would have been this guy. This is a perfect example of not really doing the work, but like looking at the answers and seeing what's left. So it says 180 minus 2 of the X and Z. No, it needs to be half of the X and Z, because if I add those together and cut them in half, that's what it's really just getting back to X. So that's the best example I have for you. There's your answers. This time on the back, we've got, oh, I'm so sad. Okay, so right here we've got 1, 2, 3, 4, 5. Let's go down the left-hand side. I want you to try this in 3 minutes. Can you give yourself 3 minutes and try to get 3 right? Ready and go. All right, let's see how you did. A student creates, this is like a Facebook challenge, right? Where they're like, 3 apples equals 30. Anyways, he first draws a square. Then he adds a line for each of the 2 diagonals, and he says, hey friend, how many intersections can you get with this circle? So I'm sure the first thing would be like this, right? 1, 2, 3, 4. That's an option, sure. Right? And then you might think, okay, well, I can get bigger, right? And so you're right here, and so maybe you're like, oh, cool, I can get 1, 2, 3, 4, 5, 6, 7, 8. That's an option. But the best answer is right here. Because we got 3, 6, 9, 12 options. Okay, looking at the next one. Which one is the length of a foot of a hypotenuse of a regular triangle with 6 and 7? Okay, so we would draw a triangle. Legs are 6 and 7. Here's x. So we would do 6 squared plus 7 squared equals x squared. We would find out that that's 85 equals x squared. We take the square root of 85, and that's actually the answer. G. The next one, I'm so sorry, there's marker there. It says that AD is perpendicular to BD. AD is perpendicular. Okay, well, 90, that's perpendicular, the same thing. Okay, and that AD is equal to BC. Sure. Which of the following is not necessarily true? Is A to C equal to B to D? Sure. Is A to D equal to A to E? Ooh, that's not sure. A to E, B to E? Yes. D, A, B, so this guy. C, B, A, this guy, yep. E, A, B, this guy. E, B, A, yep, so it's this guy. So you just kind of have to go through it. And again, maybe you put a star there and you say, I know I can do this, but it's going to take me more than a minute. The quicker you can go, the better. Okay, but it's my job to just show you how to do it. Okay, the parallel sides of an isosceles trapezoid shown below, and I hope you realize that we do have to do some work here. It didn't give us some information. What's the distance in feet between these 2 sides? So what they're saying is, what's the height? So they're not asking us for the area where we had to do the 1/2 base 1 plus base 2 over height. Instead, they're saying, what is the height? What is this? Okay, so the first thing we have to recognize is that this is 16 minus 10. 16 minus 10 is 6, but I would have it on both sides, right? Both of those are my extras. So if I cut it in half, that's 3. And so now I'm just going to zoom in on this guy. So this is my hypotenuse, so I'd have to do h squared plus 3 squared equals 5 squared. Subtract the 3 squared to give me h squared equals 16. And the square root of 16 is 4. This is part of the Pythagorean triples. I will discuss those at a later time. Okay, the edges of a cube, so a cube means a square in 3-dimensional, are 3 inches long, 3 by 3 by 3. What's the surface area? Hey, we can do that. So again, we've got front and back is 2 times 3 times 3, which is 18. Sure you guys can see what's going to happen here. 2 by 3 by 3 is 18, and 2 by 3 by 3 is 18. And so when we add those together, we get 54. All right, it looks like we've got 1, 2, 3, 4. Work on the starring it if it's too hard or skipping it because you're not sure. But I want you to try to take 2 minutes. 2 minutes. Pause this for 2 minutes and try to get 2 right. Ready, set, go. All right, number 9 should have been a circle or a star or whatever, because I know this took me way too long the first time I saw it, because I was like, well, I can't figure out what these distances are to figure it out. Well, guess what? If this are all right angles, if this side adds up to 20, this side would add up to 20. And if this whole thing is 20, this, and this, if we like moved it down, would also be 20. So perimeter means I add all the sides, and that's why it's 80. That's such a rude question. Moving on to the next one. It's asking us what is the area. So what I would have done is done 1, 2, 3, 4. And personally, I like to write in the numbers so I don't have to think and, oops, 14, 15, 16, 17, 18. And then right here, this guy could go into here to make 19. So both those are 19. And these are both halves. And so that's going to make 20. I personally like to draw the pictures or the numbers, because otherwise I get a little lost, especially when I'm trying to go fast. Okay, they say they are collinear. Collinear again means supplementary or 180. If CAD is 76 and BCD is 47 and CBG is 140, what is ACD? What is this guy? Holy free-holies. Okay, so, oh, I didn't do this one on my previous one. We must have just ran out of time. Well, here we go. I'm going to do some math real quick. So, this is collinear, which means I can do 180 minus 140, which means that this guy is 40. And then you would need to see, I said I wish I had different color. I meant to have like a yellow out or something for this, but it's okay. Okay, do you see that triangle that I just formed? So again, a triangle adds up to 180. So if I subtract 47 and 40, 180 minus 47 minus 40, I get 93. And then again, that's linear. So 180 minus 93 gives me 87. And so then, let me see if I can use my marker. This makes a triangle. So 180 minus the 76 minus the 87. 180 minus 76 minus 87 is 17. Gracious. So we started here, found the angle, it's a triangle, subtract, found this angle, it's a line, subtract, find this angle, and then that's a triangle, so again, subtract from 180. Oof. Okay, last one. In the figure below, line L is parallel to M, which we can already see. Transversals T and U intersect at point A, and ACS, ACX is 130, BAC is 80. How many of the angles formed of LMT, all of these, is 50? How many angles are 50? Oh, thank you so much for that. Okay, so we're going to have to just do some math here. We know because of vertical angles, this guy's 80. That's 130, so I'm going to do 180 minus 130 to find out this guy is 50. This is a full triangle, so 180 minus 80 is 100, minus 50 is also 50. Okay, so vertical angles tell me this is 50, and this is 50. This is 130, 130, 130. When they ask us how many, we basically just have to find all the angles. Okay, so if this is 100, well, let's see here. Oh, now we can kind of think of it like this. So there's two parallel lines and a transversal. So if this is 50, my corresponding is 50, which means its vertical is 50. And then same thing over here. This corresponding is 50 and its vertical is 50. So let's count them up. We got 1, 2, 3, 4, 5, 6, 7, 8. C. See you next time.